Okay, so we've been using our calculators some with these when we ran into perfect squares and when we ran into numbers that weren't perfect squares and numbers that were not perfect cubes. So we used our calculators and estimated. Those days are essentially over. I may include some problems like that on the quest, but generally speaking, you will not use your calculator to express irrational square roots and cube roots, etc. All right? You are going to simplify radicals when they are not perfect squares. All right? Just like you would simplify, I want you to think of this as simplifying simplifying fractions. You would never leave an answer like 6/8, right? Or 6/12. You would always want to simplify a fraction. You always want to simplify radicals. It should be eventually be unsettling to you if you ever read something that's not simplified. I mean, a radical is not simplified. There's 3 criteria for you that basically your checklist to determine if you've successfully simplified your radical expression. Now, does everybody remember what the radicand is? Yes, number 7. So the radicand can't have any perfect square factors. So in this first example up here, I would tell you that the square root of 12 is not a simplified radical. The square root of 15 is. Does that make sense? Why is the square root of 12 not simplified based on this criterion right here? Go ahead. Well, what perfect square factor does it have? 4. Okay, it has a 4 as a factor. There's no perfect square factors in 15. So we'll talk about this. So this is not, we're going to say this is not simplified. We'll talk about how we simplify them in a little bit, but, and this is simplified, okay? That was my phone, by the way. And the reason, if you want to write down why the square root of 12 is not simplified, is because the 12 has a factor of 4. All right. The second criterion is that the radicand can't be a fraction. So you can never leave a radical expression like this, the square root of 2/5. We're actually not going to learn today how to simplify something like this. We'll learn that in the next unit. Okay, not the next unit. I think it's 8.5. We'll learn how to simplify expressions like this.
Why is it not about factor 4 with factor 2?
No, it's not about it. It doesn't have to be prime. It just can't have, and we'll see this. We're going to have tons of examples. It just can't have a perfect square factor. Okay, you'll see when we start those examples. We're going to basically attack this one a lot today, and this one a little bit. So bear with me, okay? So the radicand can't be a fraction. I mean, you can't leave it like that, right? There's things we can do to this. Just to do what's called simplified. Yes,
Why is it called not simplified? Sorry.
Because one of the rules is the radicand, and the 12 is the radicand. It can't have any perfect square factors.
So how would you simplify that?
I'll show you. Well, I will tell you this simplifies too. I'll go ahead and simplify it. The square root of 12 is equal to 4 times 3, and then we're going to use a property called the square root of a product property, and that property tells you that you can do that, right? And so you call that 2 root 3. That's how you simplify it, okay? Now, I know that doesn't look, this looks almost like it's cleaner than that, but you'll get used to the fact that this eventually will bother you if somebody left something like this. You would say, wait a minute, you can't leave it like that. You have to express it. Like on your calculator, if you did 2 root 3, you would get exactly the same thing as if you did the square root of 12. Okay? It's just like 6/8 equals 1/2. They both equal 0.5. But one of them's simplified and one of them's not. Yep.
Can we use like the factor tree method?
Yeah, but I mean, I would hope you wouldn't have to do that for something like 12.
Oh, yeah, no.
Yeah, sure. All right. So the last criterion of the three criteria here is that there can't be a radical in the denominator. You can never leave it like this. We're not going to learn how to deal with something like this today. You use what's called rationalizing the denominator. That'll be a little later in chapter 8. We'll learn how to deal with something like this. We will be dealing with ones that, you'll see, there'll be ones where we kind of dance around these two. We'll be looking at this one a lot. Okay, got it? You can't have a radical in the denominator. It's okay to have one in the numerator, but not in the, don't leave it in the numerator, but not in the denominator. Okay, so two very, very helpful properties that we'll be utilizing, be making heavy use of. One is called the square root of a product property, okay? And that property says if I take the square root of a product, that, you can count on the fact that that does equal the square root of A times the square root of B. It doesn't matter what A and B are. And again, we're talking about positive numbers here. That the square root of A times B equals the square root of A times the square root of B. You could see that with something like, if I said 4 times 9. So what's the square, what's 4 times 9?
36.
So what's the square of 36?
6.
Okay. Does that equal the square root of 4 times the square root of 9?
Yes.
Okay, because that equals 2 times 3, 4, 6, right? So you can get at it both ways. Now, why would we worry about this? This will be very helpful to us in simplifying. There is no square root of a sum property or square root of a difference property. You can't do that, all right? Like the square root of 4, like if I said not a property would be, this is not 6, let's call it 9. This does not equal the square root of 4 plus the square root of 9. That doesn't work mathematically, so don't try to, it's the square root of a product property, right? Not the square root of sum or the square root of difference, that wouldn't work. So if you did this on your calculator, this is equal to the square root of 13, and that doesn't equal 5, does it? All right. The other key property we're going to be using is called the square root of a quotient property. How do you think that works? What do you think I'm going to say that equals?
Square root of y by the square root of b.
Yep, that's it, okay. So these are simple properties. Remember what all property means. If a property means, I call them your mathematical frames. You can always count on them. They will always be true. There's no exceptions, okay? I mean, other than, B has to be greater than 0, right? And A has to be greater than 0. So long as they're positive numbers, we're good. So what would be, so just a quick example, if I had 49 over 100, right? Now we know that equals what? We don't need this property to do that. That equals what? 7/10. Does it work though if I do it like this? Still works, right? So it equals 7/10, right? All right, ready to go on the next page? Good? All right. Okay, so let's start looking at some examples now. So examples, and for every one of these, we're going to do what's called simplify fully. All right? Now I'm going to show you the real long, drawn-out way, then I'll start. There's one step I'm going to routinely skip, but just know that I'm doing that mentally. All right. So what we want to identify is the largest perfect square factor in 45. With all of these, we always want to identify the largest perfect square factors. Well, there's really only one perfect square factor in 45, and that's 9, right? So we're going to rewrite the square root of 45 as the square root of 9 times the square root of 5. Okay? Now that's the step I want to see. Now, you'll see in the solutions I don't include the next step, but know this is going on mentally. The step that I don't include in the solutions is this. But know that that's going on mentally. I'm using the square root of a product property. And then, so what do you think the final answer here is? 3 root 5. That's the way we say it. 3 root 5.
So how do you, sometimes it can be confusing if it's like an index,
Oh yeah, we'll see some of those. Like if it's a 3 or, yeah.
but like, what's the difference between that and
Well, I mean, well, first of all,
or like a,
yeah, you'll see a 3 in there. Otherwise, these are all square roots so far, but I think they have some cube roots on it.
no, I mean like, is that 3 an index?
Oh, no. No, that's a 3 times root 5. Okay, that's definitely not a root index. Okay, that's not like the cube root of 5. No. That's 3 times root 5. So we're clear on that? It's not 3 plus root 5. It's not a root index. It's 3 times root 5. And again, if you did the square root of 45 on your calculator, and you did 3 root 5 on your calculator, it's always a way you can check to see if you've got it right. If they don't equal the same thing, you've done something wrong. All right. So, 54, what's the largest perfect square factor that has?
9.
Yeah, well, 9, here's what we're going to do. We're going to write 9m squared times what?
6.
6. So what I want to do is I want to identify, including the variable expression, the largest. So I look at the number, and I say, what's the largest perfect square factor? 9. That's a perfect square itself. So I put that all together. Again, I won't include this step in the solutions, but none of this is going on. So what's my final answer here going to be?
3 and the square
Root
root.
6. Am I okay on that? Let's actually go up here. These kind of get harder going down the page. All right, so 128. So 128, what's the largest perfect, c cubed? What's the largest perfect square factor in 128 c cubed? What's the largest perfect square factor in 128 c cubed?
16. 16.
Figured that is a perfect square factor, but it's not the largest. I think 128 divided by 2.
64.
64, right? So 64 c squared times what?
2.
C, right? Okay? We okay there?
Why can't you just put 64, 62 times 2?
Why couldn't I what?
Put 64, 62, just C to the third.
Because c squared is a perfect square. It's a part of this, right? Just like I took the 64 out of that.
So you want, so there's.
Yeah, I'm putting all the perfect square part of it in one piece. And then this is 64. Again, this is a step you're not seeing me include in the solutions. What's the final answer here?
8c root. No, wait.
Yeah.
8c root 2c.
Yep, 8c root 2c. Okay? All right, so just do this one right here. I'll give you a chance to do it. You pause this for a second. Remind me to turn it back on. Okay, turn that back on now. So what did you put as your perfect square factor in this?
4.
A to the 4th, right? Times 2b. So I'm gonna go ahead and skip this next step. So what are we gonna make the 4a to the fourth? 2a squared times root 2b. You good there?
No.
No?
Why do you keep
Wait.
All right, so
Yeah, why do you keep it a to the fourth? Instead of putting it up?
because a to the fourth is a perfect square.
So you keep perfect squares.
What I did is I kind of bundled the perfect squares, right? Perfect square factor in 8 is 4. A to the fourth is a perfect square, b is not. So, but I had a leftover factor. So do you see all this multiplies back together to get that? But I chunked all of the perfect square part of it in one piece. A? No, A is a perfect cube. Yeah. All right.
How'd you get 2B?
Well, I had, remember, there's a leftover factor. When I take the factor 4 out, right, there's a leftover factor of 2 in that 8, right? And I didn't do anything with this b, so I just brought that down.
But A to the fourth is a perfect square.
That's right. That's why I included it with the 4.
Oh.
Okay. Now I skipped a step here. Maybe that's making you nervous. Let me put that step back in there. So what I next did was in my head. Maybe I better not skip that step on you guys yet. Right, because that's your square root of a product property. So I see where this became 2a squared right here. And this is now a perfect square. All right? Okay, let's do this one. All right, so 196, that is a perfect square. Do they know what the square root of 196 is? Okay, what other perfect square factors do I have in this radical? Okay, 196, that's a perfect square. Anything else that I can bundle with it that's a perfect square? Yep, one more thing. That's right, y to the second. And what else remains? What else remains?
Leave the 3xy outside.
Not yet. X, Y. There's that X. Remember, I had one dangling Y from that Y cube. Do we see how this all goes back together to get this? Okay? Now, I won't skip this step since that seems to be a little uncomfortable for you. But I'm going to use the square root of product property now. Square root of product property. Okay, so what's the square root of this? What? Y. And then times root xy. I can put this part together here, right? I can put the parts outside the radical together. So what's that going to be?
17.
Well, no, not 17, it's multiplying.
Why would 14y be outside of the radical?
Because I took the square root of it, because remember it was all inside the radical, right? So I'm taking the square root of 196 y squared, 14y.
42.
42. xy squared root xy. Okay? Fine. Now, root 300 over root 49. So what do you think I should do? I'm going to use the square root of a quotient property now.
Square root of 300 divided by square root of 49.
Correct. Right? Now, 49 is a perfect square, so I'm just going to write 7 right there, right? Now, 300 I've got to break down. What's the highest perfect square factor in 300?
100?
100, right? So I'm going to go 100 times 3, and that's root 100 times root 3 over 7. How many express my final answer there?
10.
10 root 3 over 7. Now, going back to your criteria, this is a good answer. Is the radicand a fraction? Is the radicand a fraction?
No.
No, the radicand's a 3, that's not a fraction. Is there a radical in the denominator?
No.
No. Does the radicand have any perfect square factors? No, so we're good. All right, one more page. Okay. 125 m cubed n to the 5th over 36 m n to the 7th. All right, so one thing I can do here is I can do some canceling ahead of time before I can do any distributing the radical sign. Now, I'd be careful about doing any simplifying with this until you know how to rationalize the numbers. So I'm going to leave that alone. I'm going to leave the 128 and the 36 alone, even though you could simplify, because you might end up getting to the point where you have something that you can't, that you'll have a non-perfect square in the denominator. But I'm going to make this times n squared. So what I'm doing right now is I'm canceling the common factors with the variable parts of things. So I got 128 m squared, and the end of the 5th cancels out, and I've got 36 n squared. Okay? Is that right what I did there? All I did was cancel the m out of that and the end of the 5th out of both of those, leaving, and it was n squared in the denominator. Good? Now, distribute. So, what's the perfect square factor I'm going to need to?
64.
Good loading. So I've got root 64 m squared times 2, right? Over 6n, right? Is that right? That's an m, by the way. And then I'll have root 64m squared times root 2 over 6m. So how does this clean up? So that's going to be what?
8n.
8m root 2 over 6. That should be an n, sorry folks. And I got to cancel here. I've got 4 over 3, so I have 4m root 2 over 3n. Okay. I'm going to have to shorten this assignment for you guys. We're going a little longer.
Wouldn't it be 8m?
Well, I canceled out the factor of 2 out of this 8 and this 6. Okay. All right. 3 more to do. I'm going to shorten this assignment a little bit because I'm not getting as far along as I thought we'd get to. All right. We'll do something in class tomorrow. Okay. So cube root of 125 t to the 927 s to the 6. Well, the good news here is everything's a perfect cube in this one, all right? So I'm going to distribute the radical and get 125 t to the 9 over the cube root of 27 s to the 6. Well, everything's a perfect cube here. What's the cube root of 125? 5. What's the cube root of t to the 9?
3 t to the
cubed. What's the cube root of 27?
3
Cube root of s to the 6?
s squared.
Good.
Hey, what is that?
That's an arrow.
No, on the other column.
4m root 2 over 3n.
Excellent.
Root 64m squared times root 2 over 6n.
Oh, 6, okay.
All right, sorry, things are, so let's attack this one right here. All right, so the cube root of negative 16, x to the fourth, y to the negative, and y to the third. What is the perfect square factor in negative 16? That's a little tricky.
4.
Perfect cube factor in,
Oh, perfect cube 8.
let's go with negative 8, okay? Perfect cube factor in x to the fourth.
X to the third.
Third, right. And y cubed. All right.
Wait,
now,
how is negative 8?
times. We're just going to consider negative 8 to get that negative out of the radicals. Okay.
How do we get x to the third?
Well, I'm not done yet. What are the leftover? I got two leftover factors.
2x.
Right, 2x. Okay, so do we see how all this multiplies back together to get this? Okay, negative 8, I can get the negative out of the radical, that'd be good, right? By considering negative 8 to be the perfect cube there. All right, I'm going to distribute my radical here. That is a form of distributive property. X cubed, y cubed, times the cube root of 2x. What's the cube root of negative 8?
2.
Negative 2. What's the cube root of x cubed? Cube root of y cubed? Okay?
So you just leave the cube root in there?
Yep, gotta leave it like that. All right, so let's look at this one here. 15x squared y squared over, times root 72 x squared y cubed, so back to square roots. What is the largest perfect square factor of 72?
36.
Good. X squared is a perfect square, y squared, and then what's left? What's left?
2.
2 what? 2y. Okay? I've got 15x squared y squared times root 36x squared y squared times root 2y. So what's the square root of 36x squared y squared? 6xy times root 2y. Gotta put this together now. 90 x cubed y cubed root 2y. Okay? And then finally, let's do this one, then I'll tell you I'm going to modify that sign over there. All right, so let's distribute the radical. Let's do some canceling here first. I've got root 12 r to the 7th s to the 6th t over 81 r to the 5th s squared t. So let's leave the 12 and the 81 alone. But what kind of canceling can I do here?
T and T.
So the t's cancel.
And the
I
x.
got an r squared in the numerator and s to the 4th in the numerator, right? So then I'll distribute the radical. 12r squared s to the 4th over root 81. Good? Now, what perfect square factors can I identify in 12r squared s to the 4th? 4r squared s to the 4th times what? 3 over 9. And then I'm going to use my square root of a product property. 4r squared s to the 4th times root 3 over 9. And then final answer is going to be what? 2R, S squared is correct. Root 3 over 9. Okay. I didn't give you enough time, just please stop this now.